So when I signed up for this conference, I was going to do this reactive talk, and then like 4 days ago, I emailed these guys, and I was like, actually, I've done that talk a lot, and I think I'd really like to do like a cross-platform Angular 2 talk. And then I was watching Twitter, and I was over in the fireside chats, and Mike North literally gave the exact talk that I was going to do. So if you've watched Mike's talk, literally just replace like Angular with Ember or Ember with Angular, and it's the same talk that I was going to give. So you get 2 for free, basically. So like 12 minutes ago, I was like, oh, let's go do the other talk. So we're going to go back to doing Reactive Angular 2. See what happens. So as you said, I'm an Angular developer advocate at Google. Angular's never really had a developer advocate before, so I got hired like a month ago, and my job is very much to fly around the world giving talks about Angular, which is cool, and provide like an API from the core team out to the world, but also from the world into the core team. If you're an Angular developer, you'll know that it's kind of difficult sometimes to get in contact with the core team because we're really busy. That's my job now, so you can send me tweets or emails if you have questions or comments or concerns, or if you want me to fly to your exotic destination and give a talk, I can do that too. I'm at Wormald on Twitter, so if you follow me, like I'm constantly just tweeting about Angular and Reactive and the stuff we're going to talk about today. And my GitHub is Wormald, and I have a ton of code that you can kind of play with up there. So, excuse me, if you watched Ben's talk this morning, he probably talked a little bit about observables. Ben is way better explaining them than I am. So I'm going to talk about observables and reactive kind of in the context of Angular and why we like them and why we want to use them. And for me, it kind of comes down to 3 big things. So the first is improved performance. Angular 2 is like a much faster framework than Angular 1 by default. But if you embrace some of the stuff we're going to talk about today, you can get some pretty serious performance boosts out of your applications. It's much more efficient. So observables, and again, I didn't get to watch Ben's talk, but he probably talked about things like cancellation and being able to cancel requests, which you can't do with promises. So we can do that with observables, which are really nice. And then for me, the really nice thing is like the developer experience. If you go back and look like 8 months ago when Angular started talking about using observables in reactive programming, I was on Google groups like railing against this idea. I was like, this is terrible. I really like promises. Don't take away my promises, right? And now here I am on stage talking about them, right, and how awesome they are, and kind of how awesome this idea is. So we on the Angular team, we want to kind of really embrace these things. And so let's talk about just reactive programming. In a nutshell, for me, reactive programming is kind of programming with observables. So Ben explained them this morning. I'll just go through them real quick. An observable, so it's like a promise. It does asyncy things. So it kind of handles some of the same stuff that promises do. If Ben's here, he's going to yell at me for saying that because he doesn't like it when people say they're like promises, but they kind of are. They're like arrays. They handle lots of values. So a lot of the things you can do with arrays, like map and filter and reduce, you can do with observables. They're lazy. They don't do any work until you subscribe to them, which is handy. It allows you to kind of set up your application logic and then kind of wire everything up to begin with and then kick the whole process off. They're reusable, right? You can create an observable and you can consistently resubscribe to it to do the work, which is nice. They're disposable. You can clean them up. You can cancel them. You can cancel requests. You can stop them from giving you values. And they're composable, and that's really what I want to try and show you today is using observables to kind of plug application logic together and letting you think about your application kind of as this flow of data. So just if you missed Ben's talk, and I keep saying that, but here you go, we'll just do 2 minutes on observables. Observables, you declare them, you create a new observable, and then you kind of do work inside of them, and then you can subscribe to them and get notified of values. So you create an observable, it does something kind of internally, and you listen to it, and it tells you, I'm getting a new value, or I've gotten an error, and then obviously it'll tell you when it completes. Because like a promise, right, will give you one thing, an observable will give you many things, so you need to know when it's done. So that third callback there will tell you that. Doing that work inside, so like I call it a sink in most cases, but you have this way to propagate values to the outside world. So you have a sink, and you just call next on it, and you spit the value out. And then so this would actually then render like 1, 2, 3 out to the console. When you're done, you call complete, right? So you have this thing, you're propagating values out, and then whenever you're done doing what you're doing, you call complete. It will tell you on the outside that it's done. Same thing with errors, right? If something blows up inside of the observable, you can call this error method, and it will spit it out to the console for you. And then they do cleanup, right? So this is kind of like the hello world of observables for me. You create a new observable. Inside of it, you have an interval, and every second, we're going to propagate a value to the outside world. And then at some point later, you can call this clear interval function, and it will actually then stop that interval for you. From the outside world, that looks like this. You create an interval, you subscribe to it, you get the values, and then at some point, you just call unsubscribe, and that will stop the work and stop the values coming out. So for me, developer experience, as I said, is kind of the big thing and why I really like reactive stuff. So for me, it's about making complex apps much easier to write. I think it's really, really nice once you get into this how easy it is to write this. I'm going to try and show you this today. Easier to understand, right? If you can think about everything as this sort of basic primitive, if you understand an observable and how it works, you can really look at an entire application's logic and at a glance kind of understand what's happening throughout really complex processes. Easier to test. Testing is like crazy fun. I don't know if Ben showed marble diagrams this morning, but testing is really, really fun with observables. And again, because you can describe your application in this consistent way, it's really easy to test multiple things happening, right? So a lot of input into a system where you'd have to write dozens of lines of code to test it. With an observable, you can test it in like 5 lines of code. It's pretty cool. And they're fun, right? Like I really, really enjoy this stuff. So in Angular 2, we have kind of embraced this observable idea. And like I said, at the beginning of this, when we kind of started this whole idea, I didn't really get it. And I think for a lot of people, reactive programming and observables, it's such a departure from the way you do things now that sometimes it's kind of difficult to understand. And so in Angular 2, we have, like, everything works the same way you're used to. If you're an Angular 1 dev and you've done it, all that stuff still exists. So like ng model and data binding and all of that stuff works exactly the same as you're used to. But we've added some kind of extra features on top which embrace this whole idea of reactive and observables. So in Angular 2, just as a sample, form observables. So we can create a form, and rather than using ng model and updating data values, we can listen to an observable given to us by the form. So we can listen to data coming out of it. We can also listen to the validity of the form data. So like if we have a form input that we want to make sure has at least 3 characters in it, we can listen as you type in the box and see like what changes and watch the validity of the form. Angular data binding now supports observables. So it allows you to, rather than subscribing like I was doing in those previous slides, you can actually just plug an observable right into a template, use a little bit of special syntax, and allow you to just render them straight to the view, which is handy. HTTP in Angular 2 uses observables now. And again, that's a lot to do with the fact that we are going to be really focused on mobile devices and performance and being really nice with your bandwidth. So using observables allows to cancel requests you don't care about anymore, do things like that. And then kind of the biggest reason that is probably the most difficult to understand is change detection. So in Angular 1 change detection, we do effectively dirty checking. And it means that if you update a value, Angular will kind of run through the entire application and compare and see if values have changed, and that then triggers the view to update. In Angular 2, it works in a similar kind of fashion. It's significantly more efficient in Angular 2 just out of the box. But if you use observables, because an observable tells you when data is coming out, right? Observables are pushing values to you. We can turn off change detection in Angular. We can actually say, don't do change detection on this component until the observable tells you that there's new data. And that makes some really, really, really big efficiency gains in applications when you've got thousands of rows or a lot of data. Embracing observables here really makes your application work a lot faster. Oh, I've got a slide in there that shouldn't be in there. So observables in Angular 2. So just for example, this is a form in Angular 2. In Angular 1, you would use ng model, right? And again, you can still do that in Angular 2. But this is the observable, the reactive way of doing it. So rather than saying ng model and doing data binding, this ng form control here actually allows me to kind of get an abstract representation of the control itself, of the input element or of the select element. And then in the controller or in the class, I can listen to that element and say, give me a notification every time the value changes. And so we use this ng form control syntax here, and that search input matches with that search input there. And so it allows us to, controller side, listen to the changes coming off of inputs and things like that. And then I mentioned data binding, right? So this is Angular 2's kind of ng repeat replacement. In ng1, it would be like ng repeat thing in things. In Angular 2, it's ng4 thing of things. And then this async pipe allows us to basically unwrap an observable, right? You can actually do the same thing with a promise. So you can just connect a promise to your controller or connect an observable to your controller. And this will unwrap the values for you. The really nice thing is that in an Angular 2, if you're using an observable here, if this is constantly delivering you values, if it's doing updates for you, so if you're listening to a state or you're listening to some real-time data source, when this view gets destroyed, the async pipe will automatically unsubscribe and automatically do the cleanup for you. And that really makes the whole idea of reactive and using observables like a lot more palatable because you don't have to think about unsubscribe and cleanup and all of these things that you have to think about often. So there's this meme, basically, when you work with RX, that like you have to do either stock tickers or autocompletes, right? Like, and you just take a shot every time somebody talks about them. So I figured like what we should do first is build an autocomplete, right? Let's do that. You can all take a shot while I'm doing this. So what I'm going to do is do a little bit of live coding for you, because why not, right? So we're going to build a type ahead. Can everybody see my screen there? Yes? Good. Cool. So let's just flip through this real quick. So type aheads, right? Type aheads, has anybody ever built a type ahead? Raise your hand if you've done run. A few people probably have built them. Like, did you enjoy it? Is it something you like doing, right? For me, it's not. Like, you might, right? Jared, you might, but you're kind of strange. So type aheads for me are they're a really complicated thing. There's a lot going on, right? You've got data coming out of the view, you've got to make requests. You've got to then think about, okay, maybe I don't want to actually make an HTTP call every time I type in the box, right? So you want to do debounce or throttle, something like that. Side effects are really hard to manage, right? So if you're making a bunch of requests, you're getting a bunch of requests or a bunch of responses back. They might come back out of order. They might come out, in different sort of time frames. There's a lot going on. They're leaky, right? Like if you're doing kind of a normal type ahead that ends up being like 500 lines of code, you have to keep track of things like timeout IDs and all sorts of various things. And they're really inefficient in a lot of cases, right? So if you're not able to cancel the request, so if you're typing in the box and values are going out, you can actually then you're wasting bandwidth, right? Because you've typed in the box, you've already made a request, and then you don't care about the result that you've already sent out if you type in the box again. So they're a little bit inefficient. So let's build one in Angular 2, and we'll see if this works for me on stage, right? So this is a really, really super simple, let's open up a new tab here. Hopefully this works. It does, groovy. So I've just got like a really super simple Angular application here. And we're going to build a type ahead in here, right? So the way to read this is I've got a very simple app component here. I've got a little header there, and then I've got this component, this my type ahead here, and this is this component up here. So this is like a reusable type ahead component that we're going to build, right? So let's start. So what I've got imported here is this is the component decorator from Angular. I'm bringing in RxJS. I think Ben mentioned this morning that you can like individually bring in the operators one by one, which is really nice and efficient. I'm not doing that because it takes like a little bit while to type out all the things I'm going to use, so I'm just doing the lazy way and importing the whole library, which is handy. I'm bringing in a control from Angular 2. This is that kind of abstract representation of a control that I talked about. I'm bringing in our HTTP library here, and then I'm bringing in the actual observable constructor itself. So a type ahead obviously starts with an input box, right? And so what we're going to do is just build a little reactive YouTube search thing here in a couple of minutes. So I'm going to start by creating a control. So I'm going to do search input is a new control. Notice I'm using type aheads here, so I'm going to get auto completion, and hopefully to stop me from making any kind of stupid errors on stage, because it'll complain at me before I do that, right? So this search input, we can just talk to it in the controller like that. And what I'm going to do is say ng form control. And Jared, please stop me if I screw anything up. That would be helpful. And basically what I'm saying here is like connect this input box to this search input that I've just created here. And so this search input has a value changes property. And this value changes property, you can see down here in the corner, is actually an observable, right? So I'm just going to subscribe to that to start. I'm just going to log the value out so you kind of get a feel for what this is doing here. And hopefully Webpack is going to work for me. It is beautiful. So open up the console here. Move that over a little bit. Excuse me while I just reorganize my windows for everybody here. Cool. So what I'm going to do is, as I type in the input box here, hopefully, if the gods are with me. Cool. Yes. So as I'm typing in the box, you can see each time I put a character in, it's going to spit that value out to the console for me, right? So this is kind of the beginning of the whole interaction, right? So I've got an observable of inputs into my form, right? So cool. Switch back over to my editor here. And so what we want to do with this is actually go ahead and make requests to YouTube, right? Like we want to take the input and do a query against YouTube. So what I've got going on in here, go away. I'm going to create a little YouTube service here. So in Angular, we basically have two kind of concepts. We have components and we have services. So the first one here, we're going to create a YouTube search service export class. See, this is TypeScript saying, hey, idiot, you forgot class. Good. I'm going to create a constructor in there. And we're going to use Angular's dependency injection to bring in the HTTP module that we're using here. So I'm going to do private HTTP is that. And so using the syntax here basically allows me to inject an instance of HTTP. Angular will provide that for me automatically. And I'm going to add the injectable decorator here just to tell Angular it's a service. And I'm going to go over to my type ahead here and import a little bit of awesome type completion here from /YouTube. And now I can bring in my YouTube search. And I'm going to provide this to my little application here. So basically just it makes it available for Angular to use for dependency injection, which means in here I can now bring in my YouTube service and bring that in there. And so if you've never used TypeScript before, doing this private syntax like automatically assigns the YouTube service to my class, so I don't have to do like this.youtube equals YouTube. It kind of does that for me automatically, which is nice. So I'm going to go to my YouTube service here. I'm not really going to do anything with the constructor. So I'm going to add a method here called search. And search is going to take a string. So it's the query we're going to use against YouTube, right? So we're going to call it input, and it's a string. And what we want is just get a little bit type safe here, bring an observable from rxjs/observable. And what we want is that the search input is actually going to return an observable. So I'm going to give that a type as well. I'm going to use any here and be a little bit lazy. So this is going to complain at me, right, because I haven't actually implemented this, which again is TypeScript being helpful for me. So what I want to do is take my search input here, and I'm going to return. Actually, let's do this a little bit differently. Cool. So what I want to do is first map. So what I'm going to do is, just like you can do with an array, each time I get a value coming out of the observable, I want to change it, right? I want to do something with it. So this is going to give me that value. And what I want to do, and actually let me just reorganize this a little bit so we can see what's happening. So I have a little utility function. I'm going to move over here so we can get a little bit clearer picture of what's going on. So I've got a couple of functions here. I've got like a base URL constant. So this is just YouTube's search API. I've got an API token. Please don't steal this because I'll probably get fired if you use my API token too much. And then I've got a little make URL function here, which is going to take my string, right, and then basically turn it into a kind of a full URL, right? So I'm going to map this input. So remember, this is just the characters I'm typing in the box. I'm going to map them using my make URL function. I'm going to give that value. And so now what I'm doing is subscribing to a stream of the value changes transformed into a stream of URLs. And hopefully this will not explode. Let's see. Groovy. And hopefully now if I type in the box, ignore the deprecation warning there. Cool. So each time I'm typing in the box, right, now I'm getting a URL with the query tacked onto the end of it. Cool. So what do we want to do with this URL, right? We want to make a query that we want to do something with it. So I'm going to jump back over to my YouTube service now. And this is going to take a URL now. And we're going to return this.http.get our URL. So now TypeScript stops complaining because now this is returning an observable. http.get performs a request with the HT method and returns an observable of response, right? And so now what I can do is, and so kind of the naive thought here is I'm going to map this, right, obviously. And so I'm going to do my URL, and I am going to youtube.search that URL. So again, I'm taking the value, make URL, turning into URLs, then I'm going to make this and basically map each URL into a request, right? So if I run this, what's going to happen? Yes, groovy, cool. Now what I get is a stream of observables. And this is probably not what I want, right? Like, it would be really nice if I didn't have to think about the observable at all. What I would really like is just to get the results of these actual queries, right? So what I'm going to do is instead of using map, I'm going to use flatmap. Flatmap is probably the most powerful operator in the entire RX library for me. So what flatmap's going to do in this case is it's going to transform the value, but it's going to return an observable. And instead of giving me back the observable, it's going to wait until the observable emits a value. You can do the same thing with a promise, but effectively what it's doing is flattening out the async behavior. So now, if I do flatmap, what's going to happen is instead of doing a stream of observables, what I should get, if the YouTube gods are with me, is a stream of responses. Cool. So that means it's done the request, it's waited, and it's actually spit out the response rather than the request. So what I'm getting back here is like a bunch of raw kind of data, right? So the first thing I want to do is take this data, that's data rec and res. This is something that I always forget to do, and if Ben's watching, thank you for telling me this, right? So what I'm actually going to do is, like, this is a selector, and it allows me to do a transformation on the response, so I don't have to like do another map because that gets a little bit tiresome sometimes. So I'm going to do res.json. And so what this is going to do is take the kind of raw response coming back from YouTube and parse the JSON for me. And so hopefully now, if I do another search, stop with the deprecation warnings. Jeez. Search for like cats. Yeah, I hit the filter button, didn't I? It was silly. Let's try that again. Cool. So now I'm getting the actual raw JSON coming back, right? So this is like the actual data from YouTube. Cool. So that's really like a deeply kind of nested structure. So I'm just going to cheat, and I'm going to use map one more time here. That's the response data. And what I actually want out of that is the response data dot items. And so now, I can actually get the YouTuber search results here. So I'm just getting an array of the results, right? Cool. So the kind of naive way to think about this, right, is what I would do is now let's render these results. So I can do an unordered list and an unordered list. I get no completion there, which is annoying. Li. Do the weird, wacky, angular ng repeat syntax. So this is ng repeat video of, not in, but of videos. And I am just going to, again, cheat here and just render that video as JSON. So that's a pipe there, right? And so the kind of naive way to think about this is I would do like videos is an any array. And then I could subscribe here and do videos is, just assign that. This.videos is videos. So with any luck, search for cats again. You can see it's actually rendering the results out. Cool. So that's nice, but like we can do a little bit better here. So I don't really like doing manual subscriptions. We want to kind of handle this automatically. So I'm going to just remove this. I'm going to change videos to be an observable of arrays of any's. And then I can actually, so if you kind of read this through, if I don't subscribe, what this returns is a stream of results, right? So I've taken a stream of inputs, streamed them, or transformed them into URLs, mapped those into requests, flat mapped those into responses, and then mapped that again into like the response data items. So this is actually going to return an observable. So what I can do now is do this.videos equals my search input transformations, right? And then I can use that little Angular async pipe thing that I showed you here. And so what this is going to do is going to do the subscription for me automatically and do a cleanup for me automatically if I destroy this view. And did I hit save? I think I did. Demo gods, are you with me? You are. Cool. Groovy. So now I'm actually rendering the results out, right? This is like a really complicated result snippet, something like title. So I can do like video.snippets.title, I think is the correct thing. It'd be nice if I had type definitions for YouTube, but I forgot to do that, so sorry. Cats. Yeah, cool. So that works. So that's a type ahead, right? But we talked about like efficiency, and we're not wanting to make a bunch of requests, right? So the first thing we'd probably want to do when we do a type ahead is do debounce, right? If you've done a debounce before, that's like a whole bunch of lines of code with set timeout and keep tracking of IDs and canceling them and cleaning them up, and it gets to be a big dirty mess. What you can do with Rx, which is handy, we have a built-in debounce time operator. And I can just say like wait 300 milliseconds before making the request. So now I've got debouncing built in with very little drama. So now if you see if I do quick typely, it'll wait 300 milliseconds, and is it not doing that? Where did I break? Debounce time. I don't know. We'll comment that out. That didn't happen. Ignore that. So debounce time should work, but demo guards aren't with me on that one, so there we go. So second part of this, though, right? So if we did debounce and that worked, that would be the first part of being efficient about this. The second thing is that we're making a bunch of requests now that we probably don't need to be making. So if we watch the network console here, if I turn off debounce, each time I type in the box, hello. Oh, thank you, not WebSocket requests. Let's clear that. Anybody know how to clear the network log in Chrome? There we go, cool. Should work on that, should know that. So each time I type in the box, I'm making a bunch of requests, right? You can see those all going on. I don't really care about all of them except for the last one. So handy, we're actually going to use a different operator here. So we have an operator in Rx called switchmap. Switchmap is exactly the same as flatmap, has the exact same behavior, does the exact same thing, except that it will cancel the previous observable. It will cancel anything that's kind of still backed up in the pipe, right? So switchmap does the same thing. This usually doesn't work for me in demos because it's like generally a pretty fast API, but let's see if I can get it to work. So if I type in this box really, really quickly, yes, you can see that so it's like made the request, but a new value's come down the pipe, and it's actually canceled the XHR. It's a little bit hard to see. Come on, never mind. So it's actually going to cancel the XHR, and you can see that's what the red means, right? So it's being a little bit more efficient and not kind of wasting extra requests that we don't care about anymore. And that cancels the underlying request. It doesn't just ignore it. It actually cancels the underlying XHR, which is handy. Cool. So that's like a pretty functional type ahead, debounce aside, in like, what, 5 minutes or so? So let's back to my slides here. Oh, we're all out of sorts. Cool. So type ahead's pretty easy, right? Cool. So the other thing that observables you often talk about, and you should probably do shots when you talk about it, is real-time stuff, like real-time applications. Observables are really good because they're pushing us new values, right? Anybody in here used Firebase before? Anybody heard of Firebase? A few of you? Cool. So Firebase is Google's real-time application platform. We had a really, really good library with Angular Fire and Angular 1, and it made it really easy to work with. I'm working on the team that's building Angular Fire 2 for Angular 2. And obviously, the first thing we did when we saw this, we were like, let's plug observables and Angular Fire together. And what we end up with is a really, really cool kind of project. So let's see if we can do, so it's observable powered. It's going to use Firebase and RxJS. It makes real-time really, really, really simple. And like how simple? Let's see if we can build a chat demo on stage in like a couple of minutes, right? So what I've got here, let's get rid of that. Again, I'm importing components, and I've got my Angular Fire library here. This is available in NPM already. We've got an Angular Fire service. We've got a couple of configuration bits and pieces, and then this Firebase list observable type. This is like a special flavor observable that we've created. And so what I'm going to do is provide to our application the Firebase providers, and then I'm going to say the default Firebase here is this awesome new URL for our Jazoon chat demo. So this is like a free Firebase, and you can play with these for free. You can create as many as you want for free before you actually go and deploy them. And so what I'm going to do is I got a component, and I'm injecting the Angular Fire service into it. And so the way that we work with Firebase is it's going to look actually very similar to what we were doing with the kind of previous stuff on the type head. So I'm going to say this.messages is Angular Fire.list of /messages. So what this is going to do is going to go up to Firebase. It's going to create a messages table, if you like. We're not supposed to call them tables, but it's a table. It's a Firebase list at the /messages address, and it's going to basically give me an observable of the state of the data of that Firebase. So I'm going to create that, and then what I can do is if we do something like add message, and we're going to actually pass through an L here, what we can do is, first of all, create an input, and that's going to be a type of text. And we are going to just give that an ID here. So this is like a new message. And so this little hash symbol basically lets me get like a reference to this element in the view. And then we will add a button here to actually save the message. Say send. And this is me listening to the click event of the button. So like when I press the click on the button, we're going to call this add message method. And we're going to pass through the new message element. So effectively what I'm doing is like passing the element through the class, through the controller, right? So I'll get the message or the L coming through here. And then what I want to do is do this.messages add. And so what this is basically doing is going to push a new message to Firebase whenever I call this, and we'll say like the text here is L.value, and then I'll just reset the element's value back to an empty string. And then in the view, so I've got like my input and I've got a button, and now what I want to do is actually render the messages, right? So again, this is going to look almost exactly the same as our previous demo. And we'll do li ng4 message of messages. And so again, it's messages here, links up with messages here. And I want to use the async pipe to handle that. And we're going to do in here message.text. This is the one that always blows up on me, so let's see if this works the first time. Everybody cross your fingers. Not that easy quite yet. Let's get back to our Stony tab. Yes. Not that. Come on. Firebase. No explosions in the console. It's a good start. So hopefully now, if I say hello Jazoon and send that, it pops up. Yes. Cool. And just so you can see that I'm not faking this, I'll open this up on another tab and say, it's coming through and say like, yes, this actually works. You can see it pops up in both tabs. So it's a real-time chat demo in like 4 or 5 minutes, right? And so what I want you to notice there is that really this syntax is almost the same as we're using the previous step, right? So it's really just like I have some stream of data, and I'm going to assign it to the controller itself, and then use this async pipe syntax to actually render it out. And so I mentioned earlier like consistency and composability and kind of making these things easy to understand is that once you understand what's going on here, it's really easy to look at this and say, okay, I'm just going to render a list, and I had this observable, and I can hover over it tells me it's an observable, and I can really, in like one glance, understand what's happening in this application, rather than doing like a whole bunch of event listeners, a bunch of crazy services. It makes it really, really simple to work with. Cool, so that one works. Switch back to my slides if I can find them. They are there. Cool, it's that easy. So every time I do this demo, people are like, okay, cool, type aheads and like Firebase, right? But like, what about real applications? So applications, why are they hard? Like, what's the hardest part in an application? And for me, it's managing state, right? Like when you get a big application, you've got a huge amount of state, you've got users and friends and messages and all kinds of data, and you have to keep it up to date, and you have to mutate it, and you've got services, and you got to test it. So there's a huge amount of state management going on in any kind of real application. Angular embraces this whole idea of components like Ember does and like React does. And we also embrace this idea of one-way data flow, right? And so one-way data flow kind of by default makes this whole thing a lot easier to reason about. And interestingly, observables flow data one way as well. So there's kind of a nice little paradigm here that we can work with. So for me, this is the thing that really made observables click for me, is that like, okay, not just type aheads and real-time chat demos, but also like I can treat the state of my application as an observable. So if you've ever used React and Redux, this is very much inspired by that. And so for me, like, it's important that we're learning from other teams. So we've had the benefit of a couple of years of React being ahead of us, that we can learn from these people and kind of learn some of their lessons. We can tweak it for Angular, right? Let's make it a little bit more Angularly. Let's make it work with DI. Let's make it work with the async pipe, and really kind of make it easy. So reactive state management. I created a project before I joined Google called ngrx/store, which in hindsight is a terrible name for a library, but I was trying to keep it simple. And so it's basically Redux plus RxJS for Angular 2. And so it kind of combines the best of Redux and that really kind of simple model of how Redux works, and then RxJS and this whole idea of observables. Let's not go quite there yet. And so we'll do a quick demo of this. And so this is the one that really like bakes everybody's brains. So if this doesn't make any sense at all, then don't worry about that, because this is quite a kind of strange concept. But the way that Redux works is, and the reason it's called Redux, is it comes from this word reduce, right? And so reduce is a pretty common thing in kind of every programming language. We have it in JavaScript as part of the standard library. And also, RxJS has it, reduce, right? And so the idea of a reduce and the idea of a redux is that we have state, right? So some piece of state on our application. And we're going to build, of course, here a to-do demo, right? Because that's what you do on stage, is build to-do apps. And so what we're doing is basically tracking the state of our application in an array. And then we're going to get an action here that tells us some way to change the state of the application. And so if you think about a reducer function, like a vanilla reduce function looks something like this. So you've got an array, and then I can reduce it. And what I can keep track of is the total and the value. And what I want to do is actually add the total to the value, right? So the way to read this is each time, for each element in the array, we're going to call the reduce function, which gets the previous total and the value. And that's going to start, in this case, with 0, right? So as I kind of step through this, just remember that what we're talking about here is reduce. This is not some crazy, wacky, weird programming concept. This is quite literally, I have a state, which in this case is the total, or in our to-dos application is a list of to-dos, and then some way that changes the state. So in a counter, it's just the value, and in this case, it's going to be what we call an action. And we start with an initial state of 0, and in this case, we're starting with an initial state of an empty array. And then what Redux does is sort of describe, OK, if I get a type and a payload, basically what we do is a switch statement, and it says, like, if we send you a type of add to do, then take the payload and add it to the existing state. So add to do basically says, here's a to do, here's a new to do I want to add, and return this new array with this to do added into it. Same pattern follows along. So if you do update to do, we're going to give you that to do. We're going to look through the existing state. We're going to check and see if it matches the one that we're looking for. And if it doesn't, we're going to return it. But if it does, we're going to actually update the state of that object, right? Same for completes. We're going to map through it and see, OK, do we have one that matches? If not, let's return it. And if we do, then let's update the state of that. And if we're doing a delete, we're just going to take that state and filter out the to-do we're trying to delete. And so what this looks like from the outside. So I guess the first thing to mention is that nothing in here is reactive. Nothing in here is anything to do with NGRX or Angular or anything. This is just a pure JavaScript reduction function, right? What's cool about this is that, one, it's really, really easy to test. It's pure, right? So given the same inputs, it will always give you the same outputs, which means you can test it in isolation. Once you kind of understand what's happening here, this is really easy to reason about. This is a very consistent common pattern, right? It's always going to do state and an action and return the new state. makes it easy to test. And this is like this. I actually stole this one directly from the Redux docs, right? This is not anything that I wrote. This is like a consistent reducer that you can use almost anywhere. And so in my application, if I go into my to-do app, what I've got here is a very simple to-do app. I'm bringing in a few things. So I've got my regular Angular stuff, and then NGRX provides you a couple of things. The first is this provide store function. And so what the provide store does is it basically allows you to configure the store. And the way that you can think about store, this NGRX store, is like a database in your client app, right? So we've got this provide store function and the store itself. So this is the service that we give to you. I'll talk about DevTools in just a second. I'm not going to get ahead of myself. And then this is that reducer function that I was showing you, right? So you can think about a reducer. If store is a database, then you can think about a reducer as a table, right? So you have a database of all the state in your application, and then kind of each type of state, each model, or whatever you want to call it, is represented by a single reducer. And then again, I'm bringing this observable so I can use it for type definition purposes. So in my providers here, I'm saying provide the store, and I'm giving it a list of to-dos. And so this is actually just shorthand for doing to-dos, if you've never seen that syntax before. But basically what this says is an object of to-dos, and we're providing that to the store. And so we're configuring the database, right? We're kind of creating the tables, if you like. And then what I can do is inject my store here. And again, to-dos now is an observable. So what I'm going to do, first of all, is show you kind of what's happening here. So if I start with store, and I do store.subscribe to the state of the application, what this is going to provide to me is, I'll just do a store.dispatch type of add to do, and we'll do a payload of text hello world. I'll actually move that after this. Get back to my browser window because I keep losing it. Hooray. That's not what I want. Also not what I want. There we go. Cool. Look at my to-dos app here, and I look in the console. What you can see is the application starts with an initial state of an empty array of to-dos, right? So I've got like an empty database with a list of to-dos. There's nothing in it. And then I added that to-do, and now I've got a to-do in there. So that's my text hello world with an ID. So let's take out the store.subscribe there. Take out the store.dispatch for a second. So what I'm going to do is say this.todos. So again, this is an observable of to-dos. And I'm going to say store.select. And so you can read store.select as if it was like a SQL query for like select star from to-dos in your SQL queries. I haven't done SQL query in a long time, so that's probably not the right syntax. And so I'm saying store.select to. So basically, give me an observable of the to-dos of the application, right? And then in my view, I can say, again, this is like the third time I've written one of these out hand at a time. Li ng4. I should have a snippet for this for the next one of these. To-do of to-dos. Li to-do.text. And again, we're going to use the async pipe here. And so what's cool is, again, like I'm not subscribing, and basically now I've just basically directly connected the state of my application to the view. And so if I want to then mess with this state, so let's do, oops. Again, I keep doing the same thing again and again and again. Let's do this again. Let's do an input box. We'll get a new to-do thing on it. I should have just copied and pasted this, so it would have been faster. And we'll add a button. Sorry, you can watch me type the click thing again. And we'll do add to do, and we'll pass through that new to do, and we'll add the add to do, and we'll pass through the L. And what we're going to do, the way we interact with the store, and the only way to interact with the store, so rather than like all over your services and a bunch of various disparate services trying to do state updates, the only way to change the state of an application is to dispatch an action to the store. So I'm going to say dispatch. And so again, that's a type. And so the type is just like, this is the action that I'm doing. We're going to say add to do. And then the payload, in this case, will be text of the L.value. And we will again reset the element to an empty string. So hopefully, do I have a typo? What am I doing? Say it. Yes, good catch. Thank you, everybody. That's very helpful. Cool. So hopefully this will work. Just, oh my God, go away. Watch me get lost in my console. There we go. Okay. So I forgot to add a title to the button, but let's just imagine that says to do. So like learn Angular 2. It works, hooray. And learn RxJS, hooray. Cool, and just for the sake of arguments, let's add a button that does, I don't know, let's say click complete to do, and we'll pass through the to do, and we'll say completes, because obviously you want to be able to check things off your list of things that you've done. And again, so it's complete to do, and that's going to take the to do. And then what we want to do is this.store .dispatch type of complete to do. So again, that's that complete to do action from my reducer, and the payload is the to do itself. So again, like the only way to change state in the application is by dispatching something against it. And then you guys can watch me mess up with my CSS here. So let's do, because I'm terrible at CSS, let's do a, and so this is actually me, I'm using like inline styles in Angular 2, which is pretty handy. That's for another talk though. And I'm going to say, I think it's text decoration. I think it's line through. Is that right, Jared? You're nodding your head. Is that the right CSS class for that? It is. Yes, good. Cool. And so then I can actually use class dot, excuse me, is that right? Shh, completed. Throw me off. To do dot completed. So the way to read this is if the to do has a completed property of true, then we want to apply the completed completes class to it. And so we can complete the to do, and we got a complete button. And so let's learn Angular 2. Oh my God. And learn how to type. And hopefully now, if we do, yes, cool. So I can complete, and it's going to add that CSS class, right? So that's kind of state management. So like this is a really simplistic example, right? Like this reducer is, what, like 20 lines of code? But what this allows you to do is like describe entire applications and the way that you interact with state in a very, very singular way. The interesting thing about this, though, is that if you have a big application which has a ton of reducers and a ton of data sources and like data streaming in from all other places, I mentioned at the beginning of this, like we can do some really efficient things. So from Angular, I can import the change detection strategy, which is, again, is a ridiculously long name for this to be on stage, but there you go. And for this component, I can say change detection and say change detection strategy dot on push. And what this means is instead of Angular constantly checking to see if the data has updated or if the view has changed, because we're using the async pipe here, the async pipe will actually tell Angular whenever a new value comes down the pipe, hey, this thing is dirty, go ahead and dirty check it. And so again, if you've got a big application with tons of components and huge amounts of data coming through, there's a pretty serious performance boost to be had from using the change detection strategy. I'm just going to, like, this is probably going to bite me because it might not actually work, but let's see. Make sure change detection works. It does. Good. We complete. This still works. Yes. Cool. So you get performance out of it. You get kind of really simple reasoning about this. And so like if you've never seen this before, this is probably like a pretty weird, mind-blowing concept. But this is something that's very common in React. They have this idea of Redux. And this is like a really, really old concept. Computer science has been doing this for years, and we're just figuring it out in JavaScript land. And so there's a couple of really big benefits, right? Other than easy testability, which I talked about, and change detection. The really interesting thing about this for me is that because we can basically understand that the only way to change state of an application is by dispatching an action, and that things are pure, all these recursive functions are pure, we have some very tight constraints, right? There's only some very, very specific ways to do things. And so what we can do, and you probably saw this kind of hovering over on the left side of my screen, but some really clever people, I'm going to go ahead and just restart this so you can see. Some very clever people on, some very clever people who invented NGRX or invented Redux had this idea of dev tools, right? So again, if like you're managing state in an application, it's really hard to reason about. You make a bunch of changes, you're like, how did this happen? How did I get into the state that I got into, right? So dev tools, which is this panel that's kind of hanging off on the left side here, and all I've done here is I've got like an Angular component that does dev tools just there. So I can insert this to any application that uses NGRX. And now what I can do is actually track the state of the application. So learn NGRX, learn to do apps, and learn how to type. And then I'm going to, so I'll do a couple of things here, and I'll do a complete. So what you can see is that each step of the application, move this over a bit. I don't know why that's hovering off the screen. It's CSS for you. Each kind of action I dispatched against the store here is being tracked, right? So this is I added, and then I completed, and I completed. And what's cool is that I can actually go back and do effectively time travel, right? So like if I decided that what does the application look like if I hadn't dispatched that second action, I can uncheck it. And it means that, OK, we're going to recompute the state of the application from the point that I changed that. The other thing it allows me to do is I can, at any point in this application lifecycle, I've lost it again, oh my god. I can actually log the payload out or log the state out. So like, what did the application state look like at this point? And I can see at this point it looked like to-dos array of 3. Or what did it look like at this point? Go back and look at it. And I can see at every step in my application what the application state looked like and how it was affected. And again, do time travel and say, actually, what did it look like if I hadn't done this, or this, or this, or this? And you get a big application with a huge amount of stuff. Then you can kind of say commit and save the state at this point, and then keep tracking. So like learn ng2. And basically allow you to track and step back and forth all the way through your application and see what's going on. So this is NGRX. This is open source on GitHub. This is a project that I started, and a really, really awesome community of people has picked up and kind of run with. DevTools, I said it was initially implemented in Redux, and a couple of people from our community put it together in like a week, which was really awesome. So that's the end of the demos. Coming soon to Angular. So we are kind of new to this whole reactive idea, this whole observable idea. So one of the things we want to get is declarative observables from the view. So you saw me there like doing a lot of messing around where I was like getting element references and then like passing them through and doing this on the other. One of the things we want to do is make observables from the view much, much easier to do. We can do it with forms right now, but we want to do it with button clicks and drags and like every event from the view we want to be able to represent as an observable. We want to be able to use marble testing from RxJS, and I don't have time to show you that, but marble testing is really super cool. And if you just Google like RxJS marbles, there's some really interesting information on that. Better documentation on observables and RxJS, because they are a little bit brain-bending sometimes. And obviously more examples and more blogs. So Gerard, now you've seen this, you can go ahead and blog about this, okay? Cool, so that's the end, subject.completes.